Hi everyone, my name is Jackie Huang. My project name is Hepatocellular Carcinoma Survival Status Prediction. Let's look into the dataset first. I obtained the data from UCI Machine Learning repository. You can see there are total 165 observations and 49 features here. Let's look into the detailed information of these features here. The first 23 features, they are categorical features like gender, symptoms, alcohol, and so on and so forth. And then the next 26 features, they are numeric features like age at diagnosis, grams of alcohol per day. But most importantly is this class feature. This is the one that I want to predict. This is a categorical feature. 1 stands for patient survives, and 0 stands for patient died. So basically my purpose of the project is to develop a computer-aided method to help the doctors when they are diagnosed the patient with hepatocellular carcinoma, and also the estimation of the survival status of these patients. Let's look back to the code. So the first thing I did was data exploration. You can see the structure here is a little bit unclear because seems the integers and the characters, they are mixed with each other. And so my first work was to reconstruct the data set. As you can see, this is the new structure of the data set. It's more clear than before. Factor and integers, they are separated. But still have a lot of question mark and NAs. I will deal with them later. And then I did the visualization with the numeric variables. As you can see, there are so many distribution schools. Yeah, but seems this distribution schools doesn't hurt my later data building, model building, so I didn't deal with them. And then I did the detection of outliers. I used Cook's distance, this method, to detect the outliers. I calculate the outliers of each feature, and then I put them together, and then show the top 5 names of the feature that contain the most number of outliers here. So this is the name. And also I calculate the range of the outliers here. It's ranged from 0 to 19. Since my data set is somewhat small, so I won't remove these outliers. And then I did a correlation analysis here because my survival status is the feature that I want to predict. So I just calculate the correlation between my survival status with the rest of the 49 features. And this is the result. Seems because I haven't removed the NAs yet, so I just ignore NAs here. This is the result as you can see. And next step is data cleaning and shaping. Because I have 23 categoric features, so I built a mode function to input the category features with mode. And also I tried 2 ways to input my numeric features. The first one was KNN, where K equals to 1. And I also tried use mean, but seems the performance of KNN is better. So I just choose KNN here. But I also showed my mean function here, the code. Because my dataset has a feature which is age at diagnosis, so I feel I can derive new features according to the ages when the patient was diagnosed. So I just create 3 new features, which are young, middle, and senior. And at the final, I appended the features to my original dataset. Here, I used z-score transformation to do the standardization. Also, I did dummy codes because my first 23 categoric features, they are already encoded with 0 and 1, so I just need to transfer them into numeric. I also did PCA analysis. Here, I want to say is I calculate the 10 new components, and this is the results of the components. But since the components, none of them can represent most of the variance because of the proportion of variance seems they are not big enough, and most of them are sort of even. So I don't feel create the 10 components is a good idea, but I still show my code here, and I plan to just reduce the features when I'm building the models. Here comes to model construction and the evaluation. Because my dataset is not big enough, so I just created 75% of training dataset and 25% testing dataset, as you can see here. Let's run the, I built 3 models, and the first one is logistic regression and the neural network, and also the SVM. Let's talk about logistic regression first. I can run the code here. Here's the code. So according to the stepwise backwards elimination, I remove the non-significant variables. I used here use step, and I stored all the results, the features into SIG. And then I create the formula and build the model here. I can run it. So this is the summary result of the model that I built. And also I did evaluation of fit of models with handout method using my testing dataset to calculate the accuracy. Yeah, and I also did the 95% confidence interval of other features. Next is the I created a 5-fold cross-validation. Here's the result of the accuracy of each time's cross-validation, and this is the average. Let's run the code. Here's the result. So next, I just mentioned I did neural networks, and here's the code. I just run the code. And then I did evaluation as well. The accuracy is a little bit worse than the logistic regression. Also the 5-fold cross-validation, the same thing. And the last model is the support vector machines. Here's the code for building the model. This is a summary. And also using the testing dataset to calculate the accuracy. It seems the accuracy is the worst among the 3 models. Because of the SVM is a margin-based classifier, so it's a bit hard to apply the confidence interval to my categorical feature. And I also did the 5-fold cross-validation, the same thing. And the tuning of models. Here I just change some parameters of these 3 models when building, and it has improved the performance. The accuracy for the logistic regression is better, well, after tuning. And also the SVM model, this is better as well. The last one, the neural network. So after tuning, the accuracy improved as well. So the last thing that I did was comparison of these models. I just used AUC to check the performance of the models and compare with each other. Here's the result. As you can see, it's almost the same thing that as I validated before. So the performance is logistic regression, better than neural network, and better than SVM. So this is my project. Thank you.